All right, let's do this. 3.4 Library of Functions. Today, we'll just cover more properties and characteristics of functions, and then we will jump into piecewise functions, which are really important to know how to actually read and utilize. So let's first start off with graphing a function and answering the questions below. We are given the square root of x. So let's go ahead and graph it. All right. And the easiest way to graph a function is to pick points. So that's what we're going to do. So we are given f of x equals the square root of x. And then I'll put my xy chart here and just pick points. So we're taking the square root. We know we can't have any negative. And since it's a square root, we're going to want to pick perfect squares. So 0, 1, 4, 9, 16. I could keep going, but we want to know what's going to fit in our graph. So square root of 0, 1, square root of 0, 0, 1, 2, 3, 4. Okay, excellent. And then go ahead and plot it. So we have 0, 0, 1, 1, 4, 2, 9, 3. All right. And then connect. And that is what the square root of x looks like. Okay. Now, since it is graphed, we can go ahead and answer the questions above. And we want to know if it's even, odd, or neither. Well, remember, to be even, you will be symmetric about the y-axis. So if we're symmetric about the y-axis, we would have another piece of graph in this quadrant. So this function does not reflect over the y-axis. So it is not even. And then, to be odd, you have to be symmetric about the origin. Well, if we're symmetric about the origin, this means we should have some graph down here, which we do not, which means the graph is not odd. So since we are not even and not odd, we are neither. Okay, and then B correlates with A because it wants to know where the graph of the function is symmetric. Is it symmetric with the origin or the y-axis? Well, since it's neither, then we're going to have none. I cannot write. There we go. Okay, and then next says determine the intercepts. All right, well, we see by looking at the graph, we only have an intercept, an x-intercept, and a y-intercept are both at 0, 0. Okay. And then next says, what is the domain and range of the function? We'll look at your domain first, right? And I'll put that down here. So let's zoom in. All right. So for my domain, we see that, and remember, domain deals with x values. So we see that the first x value we start at is at 0, 0. And as well, the point is closed. It's not an open circle. So this means for our domain in interval notation is going to be bracket 0. And since it's headed to the right, it's headed towards infinity. So you get bracket 0 to infinity, and you get parentheses. Okay. Or whatever notation it wants, you can also put it as x greater than or equal to 0. Okay. And then if you go for the range, well, range deals with y values. So what y value do we start with? What is the smallest y value that we start with? And again, that happens to be at 0. And now we start at 0, and we see that this graph is starting to increase towards positive infinity. So my range would also be 0 to infinity. And to put that in interval notation, in set notation, we would say y greater than or equal to 0. All right. So domain and range is done. And then it says, what intervals is this function increasing or decreasing on? Well, let's zoom in again. And remember, for intervals of increase and decrease, we look from left to right. So this function, if you look at it, it starts at 0 and is just constantly increasing, right? Constantly increasing. So we'll say increase, and I guess we'll use my MATLAB notation, right? It's going to say increase from, actually, we'll use my notation, and then I'll put my MATLAB notation next to it. So we increase from 0 to infinity. Or my MATLAB might want 0 to infinity. All right. And then last one is, does it have a maximum or minimum? All right. So last part, look at it again. Looking at the graph, it starts at 0, 0. So 0, 0 is the lowest point of the graph, which means we have a minimum at 0, 0. And since this table is headed towards infinity, there is no maximum. All right. And there it is. That's finding the characteristics out of a function based on its graph. Okay, let's do it again. All right. This one is going to give us the graph of 1 over x. All right, so once again, graph 1 over x, so make an XY chart. And make an XY chart. And now it's 1 over x. So what numbers can we pick, right? What numbers do we pick? And honestly, pick whatever you want. I'm going to go with, I know for this one we'll need a lot more points. So I'm going to do negative, I wonder if negative 5 to 5 will work. Why not? Negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Okay. And now we'll plug those in, and I'll get negative 1/5 or negative 0.2, and then negative 1/4 or negative 0.25, negative 1/3, which is negative 0.33, repeating, negative 1/2, negative 0.5, and then negative 1 will give me negative 1. And what happens if I plug in 0? If I plug in 0, I'll get 1 over 0, which is undefined. Okay. Actually, I might need a little bit more points. So let me do this instead. I'll leave 0 there. Actually, no. Let me get rid of 0. And then I'm going to do, watch, I'm going to do -1/2. And then negative, let's see, yeah, -1/2, -1/3, -1/4, and then I'll choose 0. Okay. And you'll see why I chose these numbers. So once again, now, if I choose -1/2, here's what happens. You get 1 over -1/2, which means that you will reciprocate this fraction, and I'll just end up with 1 times -2 over 1, which gives me -2. So with that being said, all these numbers become -2, -3, -4, and then undefined. Okay. And then for the other side, let's choose the same exact numbers. 1/4, 1/3, 1/2, 1, 2, 3, 4, 5. And I'll get 4, 3, 2, 1, 0.5, 0.33, 0.25, and 0.2. And of course, yes, you could have used a calculator. But where's the fun in that? Okay, so now let's go ahead and plot this. What's good enough here? Perfect. Okay, so at -5, I'm at -0.2. So 1, 2, 3, 4, 5. I'm basically almost touching the x-axis. 3, 4, 5. So somewhere around there. And then at -4, not much higher or lower. And then at -3, same thing, getting there. -2 in the middle. And then -1, -1. Hey, look at that. Finally a point. And then at -1/2, we're at -2. 3, 3, we're at 4. 1/2, okay, yeah. 3, and then 4. All right, so what does this graph look like? Well, it looks like this. So if you keep choosing numbers towards -infinity, you're honestly going to get really, really close to the x-axis, but you're never going to touch it. And if you keep choosing numbers closer to 0, you're going to get closer and closer to the y-axis. But as well, never touch it. So here's what your graph looks like. And the reason why you'll never touch the y-axis is because on the y-axis, x is 0. So what happens when x is 0? The function becomes undefined. So we'll never ever touch the y-axis. And we'll never touch the x-axis, but that comes, we'll learn about that at a later time. We're just trying to graph it now. Okay, and now finish the rest of the graph. So now just take all the numbers and make them positive. So 1/4, you get 4, so we'd be somewhere around there. 1/3, you get 3. 1/2, you'd get 2. At 1, you get 1. And then 2 is 1/2, smaller, 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 until you get towards infinity, right? And then up here, same thing. All right. And what this graph looks like is basically the same thing as you see below. Okay, there it is. All right, so once again, answer questions about it. Even, odd, or neither. If it's even, do we reflect across the y-axis? Does this graph reflect in this quadrant? No. Does this graph reflect in this quadrant? No. So we do not reflect over the y-axis, which means we are not even. Do we reflect across the origin? Does this graph reflect across the origin here? Or said the other way, does this graph reflect across the origin there? And that answer is yes. This function is odd. And another way to prove that it's odd is, again, look at this point. 1, 1. If you are an odd function, that means at this point will reflect across the origin and become -1, -1. All right. So we are odd, which means we can answer part B, which says, determine whether the graph is symmetric with the origin or y-axis, and since it's odd, we are symmetric with the origin. Okay. Then it says determine the intercepts. Do we have any intercepts? Do we touch the x-axis or do we touch the y-axis? And that answer is no. We will never touch the x-axis and we will never touch the y-axis. So we do have no x or y intercepts. So none. None. Well, my n looks like an h, but my other n looks regular. Whatever. All right. Okay. Then this says find the domain and range. All right. We'll look at the graph and the XY chart. So domain, you start with the smallest x value, which means where is this tail headed? This tail is headed towards -infinity. So my domain starts at -infinity, and as my graph comes, it has to stop at 0, because based on my XY chart and based on my graph, does this function exist at 0? And that answer is no. The function becomes undefined, which means we stop at 0 and then we union the next set and continue at 0 and head towards infinity. So 0 to infinity. Okay, and then what's the range? Well, my range, just like domain, starts at the smallest y value. So now, where is this tail headed? That tail is headed towards -infinity, and as we come up, once again, we have to stop at 0. And then union, and guess what happens? We start back at 0, and we head towards positive infinity. Okay, awesome. And then next is intervals of increase or decrease. So we're reading the graph from left to right. Let's look at the left side first. This graph is on the left side is all decreasing, right? Maybe the whole thing's all decreasing. So let's see. We decrease from -infinity to 0. So this is all decrease, right? And then looking at the top right, we also decrease from from 0, don't want to run out of space, from 0 to infinity, because this is all decreasing as well. So there were no intervals of increase. All right. And last one is max or minimum. Well, there is no low point and there is no high point, so there are no max or mins for this one. Okay, awesome. So those are just more characteristics of functions. Graph it out. How do you graph one? Pick points. That's all you have to do. Pick points. Okay. Okay. So piecewise functions are functions made using different output formulas for different pieces or parts of the domain. So for number one, we want to evaluate the piecewise function based on the x value given. Now, to read a piecewise function, we see that in order to be able to use the first part of the function, x plus 1, the only way to use this function is if we pick x values that are less than -2. That's the only way to use this function. So if there's an x value less than -2, then we are allowed to use x plus 1. Okay. But then, for the next piece, we're only allowed the output function of 5 if we are given x values between -2 and 3. And then for the last one, we're only allowed to use the function x squared if we are given values of x greater than 3. That's it. That's how it works. Know how to read the restriction, and when given a number, know how to piece it together. Knowing the number, knowing the restriction allows you to know which function to use. Okay, which means let's try it out. So for the first one, we have f of -5. So remember, this is the x value. So now we look over at these restrictions and we wonder, where does -5 fit? Is -5 less than -2? Of course it is. And since -5 less than -2, we get to use the function x plus 1. And we're going to plug in -5 for x. All right. Which means you'll have -5 plus 1, which will give us -4. All right, second one, f of -3. Again, check your restrictions. Is -3 less than -2? And again, that answer is yes. Okay. Uh-oh, laptop's being slow. There we go. Okay. So that means we get to use the first function again. So you'll get -3 plus 1, which will give us -2. All right. There we go. It's okay, laptop. We're going to be okay. All right. All right. Let's see. And then for the third one, f of 0. So now we check, and is 0 less than -2? And that answer is no. Is 0 between -2 and 3? And that answer is yes. Since 0 is between -2 and 3, the output is going to be 5. And that's it for that one. All right. And now 3. 3 is definitely not less than -2. So that's out. Is 3 in between -2 and 3? Well, look at the restrictions, right? This inequality says that we can be less than or equal to 3. So since x is 3, we can be less than or equal to 3. This means, again, we get to use the output of 5. All right. And then for the 5th one, f of 4. Look at our restrictions. Is 4 less than -2? No. Is 4 in between -2 and 3? Definitely not. Is 4 bigger than 3? Yes, which means we get to use x squared. So we'll get 4 squared, which will give us 16. Last one is f of 10. 10 is definitely bigger than 3. So once again, we get to use x squared, which we get 100. Okay, awesome. So that is evaluating a piecewise function based on restrictions and based on the x values you are given. You piece them together, right? Okay. Now let's graph a piecewise function. So here we're given g of x equals 1/3 x plus 3, and we can only use this function if x values are less than 3. And then we're given g of x equals -x if we are given x values greater than or equal to 3. So the first thing we want to do is graph. So just like we did in the beginning, I'm going to make an xy chart. So for the first function, I'll put it right here. So we're going to have x and y equals 1/3 x plus 3. And right above it, I'm going to put the restriction. So 1/3 x plus 3. And right above it, I'll put the restriction, just so we remember what numbers we can pick. So x less than 3. Okay, because again, this restriction tells us what numbers we can use. And we have to choose numbers less than 3. So this means I'm going to start at 3. And remember, we are plugging these numbers in for x, which means that we're going to get fractions. So we don't want to graph fractions. So the best thing to do here is to get rid of fractions. So the numbers we're going to choose are going to be multiples of the denominator, 3. So the next number that is less than 3 and is also a multiple of 3 is going to be 0. And then the next number less than that is also a multiple of 3, -3, -6, -9. That's probably all we need. All right, now take these numbers and plug them in to this function for x. If I plug in 3, I'll get 1 plus 3, so I'll get 4. If I plug in 0, I'll just get 3. If I plug in -3, I'll get -1 plus 3, so I'll get 2. And you see the pattern on the right side, 4, 3, 2, 1, and 0. All right. Now, one thing to notice is that can we actually use 3? What does the inequality say? x has to be less than 3. It doesn't say less than or equal to 3. So what this does to our point, 3, 4, is actually it makes it undefined, which means we'll get an open circle. Undefined, which gives us an open circle. Okay, and the reason for that again is because the inequality only states less than 3. If it said less than or equal to 3, then that point would be defined and not an open circle. All right. Well, let's see what that looks like on the graph. 3, 4. Let's go ahead and plot that. So 3, 4, 1, 2, 3, 4, open circle. And now plot the rest. 0, 3. And then negative 3, 2. Whoops, that's not 3. There we go. And then negative 3, 2. And then negative 6, 1. And then negative 9, 0. So our graph looks like this. That's too big. Okay, that's first part of the piecewise function. Now, we want to graph the second function. So negative x for x greater than or equal to 3. All right. Make sure I have the right one. Good, x greater than or equal to 3. Okay. And once again, follow the restriction. It tells you what numbers to use. So you'll start at 3 and just choose numbers bigger than 3. 4, 5, 6, 7. That's probably all we need. And plug them in to y equals negative x, which means they all will just become negative. Okay, and now this time, look at the restriction. Greater than or equal to 3. Can we use 3 on this one? And that answer is yes. This point will be defined, meaning it will be closed. All right. Now let's see what that looks like. So 3, negative 3, right there. 4, negative 4, 5, negative 5, 6, negative 6, 7, negative 7. And our graph looks like this. Okay. There it is. There's the first part. We have graphed it. Now the next part is look for the domain of the function. So let's zoom in. And let's look at the domain. And remember, domain starts from left to right, smallest to larger number. So looking at the graph from left to right, this tail, these x values are headed towards negative infinity. So we put negative infinity. And then coming to the right, so here is 1, 2, 3. Okay. So as we approach 3, we see that we come to an open circle. But then, if you look below, we also have a closed circle. So what this means is that since 3 has an open circle and 3 has a closed circle, this means that the function is defined when x equals 3. So what I'm trying to say is that we will state that the domain is continuous from negative infinity to infinity because of this defined point. So to make it even easier, a defined point overrules, overwrites a undefined point. So this means that the function is fully continuous only because there is a defined point at that value of 3, which means that this domain will go from negative infinity to infinity. All right. So if it still sounds confusing, which it probably does, let's pretend that this point is open, right? The red dot down there, or pink dot, whatever it is open. This means that if this was the case, you had 2 open circles, 2 undefined points, then your domain would instead be negative infinity to 0, union 0 to infinity. But since it is defined, since one of the points is defined, this means that this function can exist at 3. Therefore, the domain is all real numbers, negative infinity to infinity. Okay. All right, so that's the domain for this function. So tricky, definitely. I mean, just look out for it. A defined point will be stated over an undefined point. All right. B, intercepts. What x-intercepts and what y-intercepts do you see? Well, the first x-intercept I see, and the only x-intercept I see, is at negative 9, 0. That's the first one. And then there are no other x-intercepts, but I have a y-intercept at 0, 3, right? That one is at 0, 3. So 0, 3. Okay, perfect. And then the last one, what is your range? And once again, range deals with the smallest y value. So we'll read from, we could say from the bottom of the graph to the top of the graph, because where is this tail headed? This tail is headed towards negative infinity. And then we come up and we happen to stop at 1, 2, 3 at negative 3. But then the question is, does the function above it also exist at negative 3? So is there an x value I can plug in that will also give me a y value at negative 3? This is all going to depend on how we write our range, right? So let's say that to get that negative 3, y is going to have to be what? Negative 12, negative 15, negative 18, I think. So if you look at the xy chart for 1/3 x plus 3, if I put negative 18, that'll give me negative 6 plus 3, which will give me negative 3. So I guess essentially to put it together, since this graph is headed to negative infinity without stopping, this means that my y values will also not stop. So my y values will exist from negative infinity to infinity. All right. Okay. And again, to touch on that, let's just say that this graph above stopped here at this point, right? It stopped there. Then my range would be a little different. My range would say negative infinity to -3, union, and if it stopped at this point, which I think is at 1, it would go from 1 to 4. So it all depends how the piecewise function looks. So again, it's very tricky to look at it. There we go. Okay. And I think that's it for this piecewise function. Handle these the same way. Make XY charts, graph them, find the domain, intercepts, and range. All right. Okay. And look at that. Last one for this one. All right. Graph the function g of x equals x plus 3 for values of x between -2 and 1. G of x equals 5 when x equals 1. And -x plus 2 for all values of x greater than 1. So let's graph it. And once again, XY charts for every single function. So x and y equals, what do we have? X plus 3. And we can only use this function if my values are between -2 and 1, where -2 is included. And what's great about this double inequality, or what's it called, compound inequality, it's actually telling us what numbers to use. Even better, it says choose numbers from -2 to 1. So that's what we'll pick. -2, -1, 0, 1. And now plug them into x plus 3. If I plug it in, I'll get 1, 2, 3, 4. But take note, look at your inequalities. First is, can we use -2? And that question is, or that answer is, yes. It says less than or equal to. So we can definitely use 2. So that's okay. That'll be a defined point. Can I use 1? Look at that inequality. That says x has to be less than 1, not less than or equal to 1, which means at this point will be undefined, meaning another open circle. All right, so let's go ahead and graph that one. So -2, -1. -1, 2. Oh, wait, I keep messing that up. -2, 1. -1, 2. 0, 3. And 1, 4, which will be open. So here's what the first function looks like. That's it. That's all there is to it. All right. All right. The second part of the piecewise function, we do not need an XY chart for. This is giving us a point. All this says is plot this point. It says when x is 1, the output is 5. So this is saying when x is 1, the output is 5. That's it. Nothing more to it. No XY chart. It's giving us a point. So go ahead and plot that point. And since it says x can equal 1, this point will be closed. So 1, 1, 5. That's it. Not that crazy, right? All right. And then the last one, which we will make an XY chart for. X and Y equals negative x plus 2. I'll put the restriction right above it, x greater than 1. And once again, it's telling us what numbers to use. We are going to start at 1. 1 and go greater than 1. 2, 3, 4, 5. Perfect. And if you're wondering how many numbers should you choose, sure, 3 points make a line, but having 5 points is just more official. Having more points, 10 points, 20 points is definitely more official, but I would say at least try to get 5 points. Okay, now plug these numbers in and to negative x plus 2. So negative 1 plus 2 is just 1, 0, negative 1, negative 2, negative 3. And can we use 1? And that answer is no, because inequality just says greater than. So once again, undefined. And graph. 1, 1 will be undefined. So right here. And then 2, 0, 3, negative 1, 4, negative 2, 5, negative 3. And this function will head down that way. Okay. Excellent. The next part is intercepts, right? Actually, no, first part is domain, sorry. Domain. All right, domain starts from left to right. So the first x value we see is at negative 2. So, and the point is defined, it's a closed point. So we'll get bracket negative 2, and then we'll come to the right, and we see we have a break in the graph. And once again, we see that there's an open circle, and a defined circle, right? And it doesn't matter how many open circles are there. If a point is defined at this x value of 1, this means this function exists at 1, and we can keep going to the right. Which means this point's defined, so it does not matter. X is defined at 1, so we just keep going this way. So our graph has a domain of negative 2 to infinity and beyond. Okay, awesome. And then B, intercepts. Well, look for your intercepts. First one I see is the y-intercept, which is right there on the y-axis at 0, 3. Hey, look at that, just like the last one. And then the other one is right there at 2, 0. That's the x-intercept. And then C. Range. Okay. All right. This one definitely looks a little more tricky. So first, range, start with the smallest value. Where is this tail headed? Negative infinity, right? So that's where we start. And then we come up and we stop at 1. But do we really stop? And that answer is no. Because, once again, undefined point, defined point means the y values exist at 1. So this keeps going. So since that point is defined, we keep going up, and now we have an actual break, right? We have a break when y is 4. So and that point is an open circle. So it's going to be negative infinity to 4, not included. And then it begins again at 5. So 5 is included. So the way we state this is union bracket 5. That's it. Negative infinity to 4, union 5. All right. How does my math lab want it? I think for this, I think MML says your range is from negative infinity to 4. And I think it says with set number or something like that, with set number 5. I think it's something like that. We can look at it again. But other than that, that is piecewise functions. So to graph them, make XY charts, know your restrictions, know what numbers to pick, and graph it. Make sure you know what means an open circle, what means a closed circle, and find domain and range. Domain and range is definitely tricky on piecewise functions because now you're going over defined points and undefined points. Just remember that a defined point will be stated over an undefined point. Stated overrules, overwrites an undefined point. Because if you have a defined point, that means the function exists there, which means your domain can keep going and your range can keep going. All right. These are things to think about, not now, but keep in your head for when you get to calculus. In calculus, we learn about continuity of functions, what makes a function continuous, and what makes a function discontinuous. But like I said, you won't really see that again till calculus. Just keep it back there somewhere. Okay, that's it.